Hi guys, so here are the big ideas for the IS-20 notes for part 1. So this has to do with the significance tests for the difference in two population proportions. So I want to point out the common hypotheses. All your problems are going to use a null hypothesis of P1 minus P2 equal to 0. It is possible to run tests where we do not think that the proportion is the same and we set this value equal to something else, but it's not within the scope of this class. We will always make our baseline hypothesis, our null hypothesis, that the two proportions are the same. So then the alternative hypothesis is always going to be P1 minus P2, but you can do whichever one fits your situation. Is it less than, like it was for the underrepresented STEM students? Is it not equal to, if you're just looking to see if they are different, you don't care which direction they're different, just different? Or is it greater than, if you want the first to be greater than the second? Okay, so those are your common hypotheses. Then we learn this new thing called P-bar. This is when both sample proportions are combined. So we take the successes in the first sample plus the successes in the second sample and divide by the sample size of the first sample plus the sample size of the second sample. We essentially make it one large sample. Don't think of it as a distinguishment between the two groups. Okay, so then our mean, we already talked about this up here, it's P1 minus P2. But again, since our hypothesis is always that is equal to 0, or null hypothesis anyways, that mean will always be equal to 0. The standard deviation is also a little bit different from what we saw up here because, again, we don't actually know what P1 and P2 are. We're just hypothesizing that they're the same, that their difference is 0. So we have to use that pooled proportion, assuming that the two samples are coming from the sample or same population, we combine them. So we use P bar and Q bar here. The only difference is N1 and N2. Okay, so then we draw a normal curve, and again, the mean will always be 0, and then its standard deviation will be what we've written just right here. Okay, in the next video, I'm going to talk to you about confidence intervals.